Good evening. What is going on? Okay. So I completed the dimension part. You have written the dimension of the most of the quantity we have discussed. Hi, good evening. Good evening. Good evening. Personal chat is going on. Okay, good. Hi. Good evening. Good evening. Okay, so I completed the dimension part. Okay, so few points I am saying that you have to remember. Okay, then on that basis we will do some question also. Good evening. Good evening. Okay, now listen. Okay, so there are some quantities like for the theoretical question and some numerical question we will I'm telling the some point. So there are so many quantities, they have same dimension, means different quantity may have same dimension, that everybody know or not. Different quantity may have same dimension. There are so many example, and in the later also you will learn so many example also. Okay, so different quantities may have same dimension. Everybody agreed with that or not? So many examples are there, like surface, later you will learn surface tension and spring constant. They will have the same dimension, but they are the different quantity. Torque and work, they are different quantity, but they have the same dimension. Okay, so first point is what? Different quantities may have same dimensions. Okay, everybody got example? If you want to write, so for example we can say what? Work and torque. Torque, maybe you know right now, maybe you know or don't know. Work, basically we are using the formula what? F into D, force into displacement. So force dimension MLT minus 2 and displacement dimension is what? L. Now here torque is what? R cross F. R cross F. R is also the perpendicular distance. Ultimately it is a distance. Okay, so R is the L and force is what? MLT minus 2. So both will have the same dimension, but they are the different quantity. Okay, stress and pressure. Okay, completed. So there are so many examples are there. Okay, like in the morning I said frequency and the velocity gradient. Frequency and the velocity gradient in the morning I said they have the same dimension. So there are so many quantities are there. They are the different, but they will have the same dimension. Okay. Number 2, there are some quantities those does not have dimension as well as unit. Okay, so there are several quantities, some quantities we can say they don't have the unit as well as dimension, like stress later you will learn. Stress is what is the formula of the stress? Change in length upon original length. So change in length is what? Change in length unit is the length unit, and upon length unit. So length upon length, there is a no unit and there is a no dimension. So strain is the example that it does not have unit as well as dimension. Refractive index in the optics you will learn, like glass refractive index 1.5, water refractive index 1.33. It does not have any unit, it does not have any dimension. Okay, because the refractive index is the ratio of the velocity of light in vacuum to the ratio to the velocity of light in the medium. So basically it is a ratio of the two velocities. So velocity upon velocity, unit will get cancelled out. So there is a no unit, no dimension. Okay, relative density also we can say. So there are the so many quantities that does not have unit as well as dimension, like strain, refractive index. Okay, specific gravity or the relative density, that is also the one example. Okay, so see how much marks you got. Okay, so next one is what? There are some quantities those does not have dimension but they have unit. Who will say the example of this? So there are some quantities they don't have the unit as well as dimension. Another I am saying what? There are some unit they have the some quantities they have the unit but they don't have dimension. The example is what? Plane angle and solid angle. Already we have learned. In 2022, directly they asked this question. The quantity that does not, the pair of quantity that does not have dimension, but they have the unit, and the four option they given. One option was what? Plane angle and solid angle. Okay, 130 plus. Very good. Okay, very good, very good. 130 plus is the good marks in that paper. Okay. These points clear to everyone? Completed. Now next is what? How you will say, suppose I am asking this question. There is any quantity, you can say any quantity that has dimension but it does not have unit. Can you say there is any unit, you know, any unit that has a dimension but no unit? Can you say any quantity that has dimension but no unit? How much you got? See, there is no any unit. There is no any quantity. There is no any quantity that there is no any quantity. If it will have the dimension, then necessarily it will have the unit. Like suppose if it has dimension, so it will have either m, l, t, ampere or mole or candela. Any it will have any fundamental you will represent. Whatever you are representing, that will be the unit. Like suppose it has the mass or length, so you will say kg meter. If you are saying that it has the mass and ampere, then you will say what? Kg and ampere. Means whatever the quantity, if it has a dimension, any quantity, if it has a dimension, then definitely it will have unit. Everybody got or not? So there is no any quantity that has dimension but no unit. Everybody got? Okay. Okay. Now next is what? Only when. So what I'm saying, two quantities can be added, subtracted or equated only when they have same dimension. Means to add some quantity, to subtract some quantity, or to equate some quantity, necessary condition is what? They should have the same dimension. Okay. So let's see. Once state rank will come, then you will get the cutoff. Let's see, when the counseling started, then you will get the clarity about the cutoff. Okay. So everybody got this? So two quantity can be added or subtracted or equated only when they will have the same dimension. Like I am saying the example, can I write there is a meaning of this? No. Like I cannot add now, because these are the different quantity, we cannot add. Okay. So like that we cannot subtract also. Can I equate like this? No, it is also not possible, because two different quantity we cannot equate. Okay. Everybody got or not? So two quantity can be added, subtracted or equated only when they will have the same dimension. That is a necessary condition. They should have the same dimension. Okay. And it is called the principle of homogeneity. Any chance of conducting NEET again, sir? No, it will not conduct now. Completed? Now, if I'm asking, can I divide or multiply the different quantity? Can I multiply or divide the different quantity? Addition and subtraction clear to everyone? Okay, means we cannot add or we cannot subtract the different quantity. But I'm now asking for the multiplication and division. Can I divide or multiply different quantities? Yes, sir, we can. Yeah, we can. Multiplication and division, there is no any condition. We can divide or multiply any quantity. Everybody got or not? So division and multiplication, no condition is there. But for the addition and subtraction, there is a condition. They should have the same dimension. Like kg meter per second. So meter is different, time is different. We are dividing kg meter or something, kg meter per second square. We are multiplying the kg and meter. So multiplication and division we can do for any quantity. But addition and subtraction we can do the quantity when they have same dimension. Okay. Completed. Now some question we will do. If suppose I am saying this, I already discussed, V is equal to CT square. Okay, so I have given the quantity velocity is equal to AT plus B upon C plus T. Okay, any expression I gave, and I'm asking what is the dimension of A, B, and what is the dimension of A, B, and C. Okay, so here if you see this quantity, so one thing I can say AT is the one quantity, B upon C plus T is the another quantity. Okay, I'm adding these two quantity. It means they should have the same dimension, and I'm equating them with a V. So their dimension must be equal to the V. So means dimension of AT is equal to dimension of B upon C plus T is equal to dimension of V. Okay. Now, if you see the second quantity B upon C plus T, I am adding the C and T. I am adding the C and T. So when I can add the two quantity, when they have the same dimension, from this I can directly say dimension of C. Dimension of C is the dimension of time, that is equal to what? T. This everybody got or not? Why? Because C I am adding with the T, so dimension of the C and dimension of the T will be same. Now AT, if I am asking about the A, so dimension of AT will be equal to dimension of V. So dimension of AT is equal to what? Dimension of V. Okay. Now dimension of AT means dimension of A into dimension of T, that is equal to dimension of V. Velocity dimension is what? LT minus 1. Okay. Now here dimension of T is what? T. Then it will go down denominator. Then dimension of A, what we got? Dimension of A is equal to L T minus 1 upon T, that you will say what? LT minus 2. So dimension of A, what we got? LT minus 2. Completed. Now for the dimension of B, what we will do? So dimension of B upon, now C plus T. C plus T, we are adding in the denominator C plus T. Dimension of C and dimension of T are same. So who will say C plus T? What I can write in the terms of dimension? C plus T, what I can write? C plus T dimension in the dimension terms of dimension, C plus T, what I can write? Time plus time. Time plus time is equal to time. Time plus time is equal to time. And we are not applying the number, we are just dealing with the unit. So time plus time, C is the time, T is the time. So time plus time, what we will get? Time. So I can say what? Dimension of B upon T, that is equal to what? Dimension of velocity. Okay. Why? If you see this quantity will have the same dimension of this is equal to same dimension of velocity. Okay. So B upon C plus T, what I am writing? Dimension of B upon denominator dimension is what? T. That will be equal to the dimension of V. Now I can say dimension of B is equal to cross multiply dimension of V, what you will get? LT minus 1 into T. T and T get cancel out, what you got? L. So dimension of B, what we got? L. Everybody understood or not? So maybe from the Monday, the 3 tracks will be there. Next week, track 2 I will continue. Okay. Otherwise, you can write velocity as a dimension of velocity as a L by T. T and T cancel out. What is the dimension of B? That is equal to L. Okay. Completed. Next. So if suppose I am saying force F is equal to alpha T plus beta T square, then we have to find the, now chemistry no, only physics you will have, chemistry 2 tracks will be there. If force F is the alpha T plus beta T square, what is the dimension of alpha and beta? So here I am adding the alpha T and beta T square. So they will have the same dimension, and I am equating with F, so they will have the same dimension. It means I can say dimension of alpha T is equal to dimension of beta T square is equal to dimension of F. Okay. Now dimension of alpha T means dimension of alpha into dimension of T, I can say T. Okay, this I am equating. So that is equal to what? Dimension of F. F dimension is what? MLT minus 2. Then what I got? I will shift the T this side. So dimension of alpha. Dimension of alpha, what I got? MLT minus 3. Who will say what is the dimension of beta? Calculate fast, tell fast. What is the dimension of beta? What is the dimension of beta? MLT minus 2, MLT minus 4. Arena, like what you will do? This you will equate. Okay. Now for this, what we will write? Dimension of beta T square is equal to what? Dimension of F. Now dimension of beta T square, what I can write? Dimension of beta into T square, dimension what I will get? T square. That is equal to dimension of F. Okay. Dimension of F is what? MLT minus 2. Okay. Now T square will come in the denominator. Then what is the dimension of beta you got? MLT minus 4. I'm expecting that this much of mathematics everybody know it will come down T square, then it will become T to the power minus 4. Okay. Everybody got or not? So dimension of beta what I got? MLT minus 4. Dimension of alpha what I got? MLT minus 3. Up to this everybody got? Okay. Now listen. This question, same question came in the NEET 2024. Maybe you remember also. Okay. Same expression they gave, but after that they ask another they ask the other thing. Means they ask in the question F, same expression they gave, they ask which quantity is dimensionless. They ask which quantity is dimensionless. Option they given alpha T by beta, beta T by alpha, like that options they have given. Same question, everything is same, and but they were asking which quantity is dimensionless. Means we have to check the quantities that has no dimension. So options was alpha T by beta, beta T by alpha. Okay. So division they required. Division they required means if I divide the same dimension L by L, then L by L cancel out, no dimension we will get. Okay. So how I can get the quantity without dimension? If you see this, alpha what we are getting? MLT minus 3. Alpha we are getting MLT minus 3. And beta I am getting MLT minus 4. MLT minus 4. Okay. Then here if I multiply the beta T, M is there in alpha, L is there in alpha, M and L is there, beta M and L is there. Only time is the different. In the alpha T minus 3, in the beta T minus 4. If I multiply the beta with time, okay, then what will happen? Dimension, if I am saying dimension of beta T, I can say MLT minus 4 dimension of beta into T. Then what I will get? MLT minus 3. Now this beta t become equal to the alpha. Why? Alpha dimension is mlt minus 3. Beta t dimension is what? Mlt minus 3. Now if I will divide, it will be dimensionless. So which quantity is dimensionless? So we can say what? Alpha by beta t or beta t by alpha is dimensionless. Everybody got? Because alpha and beta t has the same dimension, if I will divide, so the quantity what I will get, it will not have any dimension. Okay? Everybody got? But this problem, so like particularly NEET problem, that we can solve very easy way without solving all these dimension. They ask the quantity. After reading the question, you got that they are asking the quantity which does not have dimension. The same question came in the grand test 12, Ashwin. The same question came in the grand test 12. I discussed that also. The same question, same data, alpha, beta, alpha t square, beta t square, f. All these we have given in the grand test 12. Who has last year in the Sri Gosalites, they know that. And that question we have also discussed in the paper discussion. Okay. Now, okay. So this question we can do in the another way. Like why I will find the dimension of f. There is no need to find the dimension of f directly. I can say in the terms of dimension. Okay, dimension of alpha. I can say dimension of f by t, because alpha t has the same dimension of f. Okay. Similarly, I can say dimension of beta. That is equal to what? Dimension of f upon t square, because beta t square has the same dimension of f. Now alpha, you can see alpha dimension f by t, beta dimension f by t square. How I will get f by t? If I multiply the beta with t, so beta t, what I can say? F by t. Why dimension? They are not asking the dimension of alpha beta. Why we will find the dimension of alpha beta? Directly we can use this. Now you can see alpha and beta t has the same dimension. Now I can say the alpha by beta t is the dimensionless. Everybody got or not? Completed? Completed? Okay. Next problem. Van der Waals equation you will learn in the chemistry. In the physics we will never talk about the real gases. Van der Waals equation for the 1 mole is the P plus A by V square into V minus B, that is equal to what? RT. Okay, where P is the pressure, V is the volume. You have to find the dimension of the A and B. Okay. So here P plus A by V square I am adding, and I am subtracting the B from the volume. Okay, I need the dimension of A and B. So from the homogeneity, what I can say, dimension of A by V square is equal to dimension of pressure. Okay. Now dimension of A upon V square. What is the dimension of volume? Dimension of volume is L cube. L cube, but it is what here? V square. So I need the dimension of V square. So dimension of V is the L cube, but when we do the square, it will become L to the power 6. So dimension of the V square, we got L to the power 6. That is equal to what? Dimension of pressure. Dimension of pressure is what? ML minus 1, T minus 2. Now cross multiply. Then what is the dimension of A you got? Dimension of A is equal to ML5 T minus 2. Completed? Okay. Now next is what? B dimension. So in the equation I am subtracting the B from the volume. I am subtracting the B from the volume. Then dimension of B, what I can say? Dimension of B is equal to what? Dimension of volume. Now what is the volume dimension? L cube. So dimension of B, what we got? L cube. I'm not writing the all dimension there, m to the power 0, t to the power 0. Means if I'm writing L cube, so what is the power of m? 0. What is the dimension of the t? 0. Okay. Completed? Okay. Now this is the like simple dimension based problem, means we are using the dimension of the some quantity and we are asking the question based on that. Okay. Now the another type of problem in the NEET also they ask 2 times. In JEE Main last year also, every JEE Main paper they ask that question. Last year also they asked the question based on that concept. Okay. Everybody getting? So this is the directly simple dimension based question. Now another type of problem is what? Okay, so now I am repeating what I am saying here. There is another type of problem. What they will do, like suppose I am saying our fundamental system, whatever our fundamental system is there, what is the dimension of mass? Then we will say MLT minus 2. Okay. But in the problem, what they will do, they will change the fundamental system. They will change the fundamental system. Okay. If they are changing the fundamental, like suppose they are saying the force is the fundamental, power is the fundamental, or this quantity is fundamental, what is the dimension of mass? Means they are changing the fundamental system. They are changing the fundamental system, and we have to find the dimension of the what quantity they are asking. Then mass may be not fundamental, maybe length will not be fundamental. Means there another type of problem. They are changing, they are taking their fundamental. According to that, we have to say the dimension of the different quantities. Okay. So question directly I am giving. Suppose I am saying if force F, velocity V and time t are fundamental, then find dimension of number 1 work, number 2 mass. Okay. Completed. Now listen, what I am taking, force, velocity and time. Force, velocity and time are fundamental. Then we have to find the dimension of the work and we have to find the dimension of work and mass. Okay. I will say the 2 method for this type of problem. First one is not the method. First one is not the method. That depends upon you. It will be the faster within the maybe 5 second, 10 second you can get the answer. Okay. And another is a method, means suppose the first method does not click, you are unable to relate the quantity, then you have to follow the second method. Within the 5 seconds you have to decide it. Okay. I will say the both. I will, in all the problem whatever I will discuss, that I will discuss with the method 1. You will try with the method 2. At least both you have to know. Means suppose the first method directly we cannot relate the formula, at least traditional method we will go and then we will get the answer. Okay. So here I am saying the force, velocity, time is the fundamental and we have to find the dimension of the work. $5.99 like MRP of the supermarket item. Very good. 599. Will I get the medical seat? I am 599. Why you will not get? You will get. You belongs to Andhra. Okay. So so here when the force and work dimension I need. Okay. So work dimension you need. So work and force. When the work and force will come, immediately which formula will come in the mind? Work is equal to force into displacement. Work is equal to force into displacement. Then we will write as what? Work is equal to F into displacement. I need the dimension of the work. Okay. So dimension of the work, but I need in the terms of FVT, because fundamental is what now? FV and T. So work, I need force. In the work formula, force is there. Force is the fundamental. So I have to keep the force because force is the fundamental. But displacement is not fundamental. Displacement is not fundamental. That displacement I have to replace. Now displacement, already we know the relation. Displacement is equal to velocity into time. Displacement is equal to velocity into time. Velocity is fundamental, time is fundamental. So I can say what? Displacement is equal to velocity into time. Everybody getting or not? And velocity and time both are fundamental. Then directly I can put here F fundamental. Displacement I can write Vt. V and T are fundamental. So what is the dimension of the work you got? F, V, T. Okay. Completed. Okay, now second, what I'm asking? Second, I'm asking mass. Okay, so mass and force. When mass and force you have to relate, which formula will come in the mind? F is equal to ma. F is equal to ma because force I relate with the mass. Then in the mind, which formula will come? F is equal to ma. So if I'm writing the F is equal to ma, okay, I need the dimension of mass. F is fundamental, A is not a fundamental, acceleration is not a fundamental. Okay, then I can say what? Dimension of M is equal to what? F upon dimension of acceleration. Now acceleration I have to find because A is not the fundamental. Now what is the definition of acceleration? Definition of acceleration is a change in velocity upon time. Velocity and change in velocity will have the same dimension. Then A, what I can say? V by T. A is equal to V by T. V is fundamental, T is fundamental. Now acceleration I got. Now here I can put now F upon V by T. T will go up. Then now dimension of mass, what we got? Ft V minus 1. Okay, this everybody got or not? This is the easiest way. Maybe the solving, I am solving each and every step, that's why it is taking time, but within the 5 second, 10 second you can you are the fresher for the NEET. Sir, is the NEET is tough. All this discussion I have given in the first I have done in the first lecture. Paper is not tough. Competition may be little bit tough, but only that among the few lakh students, not the 25 lakh students, they are only increasing the number. Grade 10. NEET is easy. If you are little bit IQ and all, then you can prepare for the NEET. It is tougher for the north people because the north cutoff is very high, but in the Andhra, Telangana, it is easy. Because paper is easy. If you are good in the bio, then you can do good. Okay, physics chemistry means you are not very intelligent, but you can get the good marks. Okay, so everybody got this or not? Now for this problem I am saying method 2. Okay, that method at least you have to know, means if suppose any problem you are unable to relate with this, then you can go to the method. Okay, what is the method 2? Like suppose I am saying what is the dimension of the force in the terms of MLT? Then we know that dimension MLT minus 2 means M power is what? 1, L power is what? 1, T power is what? Minus 2. Okay. Now I am changing the fundamental system. Fundamental system, what I am taking? FVT, I am taking fundamental. Okay. I need suppose I am asking for the mass dimension. So I need the mass dimension in the terms of force, velocity and time, because the force, velocity and time is fundamental. Okay. Then, but I don't know what is the force power. Force power is 1 or force power is 2. I don't know. What is the velocity power in the mass? I don't know. So what we will do first? Which quantity they have taken fundamental? I will write the dimension, like dimension of M. Suppose I am solving. So dimension of M, what I will take? F to the power A, V to the power B, and T to the power C. Why I am taking this? Because I don't know what is the F power, what is the velocity power, what is the time power. Okay, so I took the variables. F to the power A, V to the power B, and T to the power C. Okay, everybody getting or not? If I will get the value of A, B, and C, I don't know the in dimension of M, what is the dimension of force? I don't know. What is the dimension of velocity? I don't know. What is the dimension of time? I don't know. So what I did, I just take the variables A, B, and C. If I get the value of A, B, and C, then I will get the dimension of M. If I will get the value of A, B, and C, I will get the dimension of M. Okay. So first I represent the M in the terms of given fundamental FVT, but I don't know the power. That's why I took the variable A, B, and C. Okay. Now I will write the dimension. So here dimension is what? M. Here what is the dimension? Force dimension is the MLT minus 2 whole to the power A. Okay. What is the dimension of velocity? LT minus 1 whole to the power B, and time to the power C. Now total M power. Total M power, what I got? M to the power A, L to the power A plus B, T to the power minus 2A minus B plus C. This is the expression left hand and right hand I got. Okay. Up to this everybody got? Okay. Now both are equal. So their dimension are equal. So means power will be also same. So here M power is what? 1. Here A value is what? A value. So then I can say what? A is equal to 1. Okay. Then here L power, what I am getting? A plus B. Here what is the L power? Here basically I can say what? M L0 T0, because only dimension is M. It means the L power is 0. Dimension is 0. T dimension is 0. So A plus B, what I can say? 0. A value what I got? 1. Then B value what I got? Minus 1. Okay, because A value already we got 1. Now third equation for time, minus 2A minus B plus C. That is equal to what? 0. Now A value is 1. So I will put here minus 2. B value is minus 1. So minus of minus 1, I will get plus 1 plus C is equal to 0. Minus 2 plus 1, minus 1. So C value what we got? 1. Okay. Now I got the value of A, B and C. Then what is the dimension I can say? Dimension of M is equal to F. Okay. V to the power minus 1 and T to the power 1. So FT by V, we got the answer. Okay, so this is the dimension of M. This is the method. If you are unable to relate the quantity directly, then you can go through this. Okay, everybody understood or not? Completed? Okay. Now next problem, you will try, then I will say what I said. I will say all the problem with the method 1. Okay. You will try with the method 2. Okay. If energy E, velocity V and time t are fundamental, then find dimension of surface tension. So surface tension, maybe you don't know what is the surface tension, so that's why I'm writing the formula. Surface tension, basic formula we can say what? Surface tension is equal to F by L. By using for this formula, you have to say the answer. If the energy E, velocity V and time T I am taking fundamental, then say what is the dimension of the surface tension. Surface tension formula, what we have to use? F by L. L. Now listen, surface tension I gave what? Suppose that I am writing as S is equal to what? F by L. Again the same thing. When the F came, energy came. F came, energy came. Then what is the relay formula? You will relate force and energy. Energy and work, they are equivalent in the dimension. So energy I can write F into L. Here force is there in the formula. Okay, so I need the F in the terms of energy. So what is the F? Energy I can write E is equal to F into L. So F, what I can say in the terms of energy? E by L. Okay. Now here I can say what? This F in the terms of dimension. Dimension of surface tension I can say what? F I can say E by L. L is already there, so I will get what? L square. Okay. So E by L square. Now E is the fundamental. So E I have to keep. But L is not a fundamental. Velocity and time is fundamental. Then who will say? Like L is the displacement and all. What is the L I can put in the terms of velocity and time? So L is equal to what? L is equal to Vt. L is equal to Vt. Just now we have used in the some problem. L, what I can write? Vt. Now I can put here. So dimension of surface tension is what? E is the fundamental. L square, what I can put? V square, T square. Now that what is the dimension I got? Dimension is equal to what? E V to the power minus 2, T to the power minus 2. Everybody got or not? So this is the dimension of the surface tension. Okay. Completed? I say yes or no. Okay. You will try this question by the method 2 also. At least you have to know that how to apply the method 2. Okay. Next problem. Then find dimension of Young's modulus. Formula I am saying Young's modulus that has a dimension what? Force by area. Okay. So here if I am what I am saying, if the momentum P, area A and time T we are taking as a fundamental, then we have to find the dimension of the Young's modulus. And Young's modulus formula later you will learn if you know, that is a good. So Young's modulus formula is what? Basic formula we can say force by area. Okay. Now force, here force is not a fundamental. Here force is not a fundamental. Okay. Area is the fundamental, so area I have to keep, but force I have to remove. Now momentum is there and force I required. When force and momentum both are coming, Then later, maybe right now you don't know, you cannot relate, but later as you will learn the quantity, that this method will be easy for you. Okay, so Newton's second law. Newton's second law is what? Force is equal to rate of change of linear momentum. F is equal to dp by dt. From that we got the F is equal to ma. So Newton's second law is what? Force we can write rate of change of linear momentum, dp by dt. F is equal to dp by dt. Means when the momentum you see and force you see, that you can relate. Later when you will learn, then you can maybe easily relate. So force is equal to what? Change in momentum per unit time. Now change in momentum and momentum will have same dimension. Then now directly I got the answer. Dimension of Young's modulus. I can say what? Force, I can say force is equal to what? Rate of change of linear momentum dp by dt. So that is what? P by T. P is fundamental, T is fundamental. Okay, so force I got. Area is already fundamental. Then what is the answer? P by T, and area is what? A. Then dimension of Y, what I got? P, A minus 1, T minus 1. This is the dimension of the Young's modulus. Everybody got P by AT. Completed. Okay. Okay, so suppose I gave the GHC, gravitation constant G, Planck constant H, and the speed of light C are the fundamental. Then we have to find the dimension of time. Means here time is not a fundamental. So similar question, similar concept. G, H and C we are taking fundamental. Sometime when you will read, suppose this question, can you have direct relation, any relation we are using the GH together? No. Okay, like earlier all the problem we have directly related, like force I can relate with the momentum and time. So here GH, they don't have any direct relation. Okay, so maybe the method one will be the difficult for you. So what we will do, we will in this case directly, just after reading that you have to immediately decide, no, I cannot apply the method one because the GH direct relation we cannot relate with the mass also. Okay, so then I will go to the method 2. Okay, so method 2 means what I will say, T directly we will say what? T is equal to G to the power A, H to the power B, and C to the power, I will use another variable because already speed of light C I am taking. So in the place of C I am taking D. So time I can write as G to the power A, H to the power B, and C to the power D. Okay. Now same method we will follow. Then time I can say what? T is equal to G dimension is what? M minus 1 L3 T minus 2, that is the whole power is A. Planck constant E is equal to H nu. Planck constant dimension already I said. Planck constant how I will get? By multiplying the time with energy. That will be the dimension of Planck constant. So energy is what? ML2 T minus 2. Multiply with T, ML2 T minus 1. So Planck constant dimension what I will get? ML2 T minus 1. Because E is equal to H nu. In the morning I said, okay. Everybody got? Its power is B. And C, speed of light, any speed will have the dimension LT minus 1 whole to the power D. Okay. Now total M power what I got? Total M power is what? Minus A plus B. Okay. L power what I got? 3A plus 2B. And T power what I got? Minus 2A minus B minus D. This is the dimension I got in the right hand side. Left hand side I have M0, L0, T1. Now what I will do? Equate it. So here I can say what? M is 0, L is 0. Now minus A plus B, that I can say what? 0. Okay. Then A is equal to B. For the L, what I can say? 3A plus 2B. That is equal to what? 3A plus 2B. That is equal to 0. Okay. That is equation 2. And third one, what I can say? Minus 2A minus B minus D. That is equal to 1. In that they given the options like A is equal to 1 by 2, B is equal to 1 by 2, D is equal to 1 by 2, something like that options they have given. Okay. So first one I got the A is equal to B. L, I'm missing something, na? Yeah, L, D is also there. L, 3A and here 2B and D is what? Plus D is there. Sorry. Then here I'm missing the D. So this I can say what? Plus D is equal to 0. So these three equation we got. A is equal to B, or minus A plus B is equal to 0. 3A plus 2B plus D is equal to 0. And T dimension what we got? Minus 2A minus B minus D is equal to 1. Up to this everybody got? Okay. Now first equation we are getting like minus A plus B is equal to 0. This is the equation 2 and this is the equation 3. Okay. First equation you have in the terms of A and B. Second and third you have in the terms of A, B and D. If the second and third, this type of equation you have already solved, linear equation 2 variable, linear equation 3 variable. So second and third equation, if I eliminate the D, then I will get the equation in the terms of A and B. So from the second and third, one equation I will get in the terms of A and B, and first equation is already in the terms of A and B, then I can solve. Okay. So second and third, how I can eliminate the D? If I add the second and third equation, then D will get eliminated. So then adding second and third, what I will get? 3A minus 2A. 3A minus 2A is equal to what? A. 2B minus B, that is equal to what? B. Plus D minus D, cancel out, that is equal to what? 1 plus 0 is equal to 1. That I am suppose writing the equation 4. So one equation I got A plus B is equal to 1. Another equation what I have, minus A plus B is equal to 0. That is the equation 1. Now if I add both, I got that 2B is equal to 1. So B is equal to 1 by 2. So B I got 1 by 2. Then A is equal to B. First equation you can see A is equal to B. Then A value also what I got? 1 by 2. Now I got A, I got B. Either in the 2 or in the 3 you can put their value, you will get the C value. Are everybody getting or not? So A I got 1 by 2, B I got 1 by 2, put this value, then you will get the value of D. Who will say what is the value of D? Now put here minus 2. A value is the 1 by 2. Okay. B is what? 1 by 2. Minus D is equal to 1. So this is what? Minus 1. And this is what? Minus 1 minus 1 by 2. You will get minus 3 by 2. Minus 3 by 2 will shift this side. So minus D. Minus D is equal to 1 plus 3 by 2. So what we got? D is equal to minus 5 by 2. Okay. So I got the value of the A, B and D. Now you can get the dimension of the time. Okay. Completed. So IQ measurement, there are the different ways are there to measure the IQ, but the thing is what, how you are thinking and different situation. Okay, that depends. Okay, and I never join any coaching institute for my competitive exam. Okay, so the thing is what, if you are thinking by own. You are here is what we are taking the help of the teacher with a small problem. We are not thinking, because we are thinking means it will waste our time. We are immediately going to the teacher. We are asking to the teacher, and this is the system only. Okay, so it is not increasing our brain. It is not increasing our thinking ability. So that's why if you are struggling with the question, you are getting the solution by own, you are thinking by own, it will develop your what skill. Okay. Please explain B is equal to 1 by 2 step. Here, this equation, after adding the 2 and 3, I got the equation A plus B is equal to 1. A plus B is equal to 1. Now, another equation 1. I have what? Minus A plus B is equal to 0. Now, I have the two equation in the terms of A and B. Then, if I eliminate the A, how I can eliminate the A? If I will add the equation 4 and 1. I will add the equation 4 and 1. Then A minus A cancel out. B plus B, 2B. And here 1 plus 0, 1. So 2B is equal to 1. So B is equal to what? 1 by 2. Kavita, understood or not? Okay. Kavita, understood or not? Easy process, but easy process for that you have to think. It will take time. So that's why I said this problem, because at least you have to know that this method also means, if suppose the exam you have the pressure, you cannot think that maybe problem. So at least you should know the traditional method, that if you will go through this, maybe it will take 1.5 minutes or 2 minutes, but you will get the answer. Okay. Completed? So you will try Vinay Sai, you will try the second method, surface tension problem. If you are not getting, so next class you can ask. Just give the time. Like I am saying that you have to do, now you are asking. That is a problem. Just now I said. Means here people are not struggling with the question. If one attempt they didn't get the answer, they will ask to the teacher. Maybe you are not getting the answer, so some mistake you are doing. You have to rectify your mistake by own. Why I have to rectify your mistake? If you will rectify your mistake, then you will learn the subject. So check again. Maybe you are not getting the answer. Check again. If you are not getting after that, then I will help. Completed? One note I am saying, now listen. Like suppose I am saying, what is the dimension of the sine omega t or sine theta or sine kx, anything I am saying. What is the dimension of the sine omega t, or what is the dimension of sine theta? So if I am asking the sine of any function, so sine theta means it will give the some numeric value, like sine 30 1 by 2, sine 60 root 3 by 2. So sine of theta will give the some number, and numeric constant does not have dimension. So if I am saying the sine omega t or like sine theta, then I can say it will be dimensionless. Okay. Similarly, if I am saying e to the power exponential, e to the power something, so e is the number 2.7 something. Okay. So number to the power anything we are putting, then it will be what? Dimensionless. So trigonometric function will be dimensionless, like sine theta, cos theta, tan theta. It will be dimensionless. Exponential e to the power x, e to the power anything, like it will be dimensionless. Log of something, we will never take the like log of any number you are taking. You ultimately will get the some number, and numeric constant does not have dimension. So exponential, e to the power x, log of any input, or sine trigonometric function, they will not have dimension. This is clear to everyone. Second, I can say like sine theta. Sine theta, what is the input of the sine? You are putting the angle theta. Okay. And we know that theta is the dimensionless. It has a unit, but it does not have dimension. So it means what I can say, sine theta and theta, both are the dimensionless. Means input of the sine and output of the sine theta, both will be dimensionless. Input of the sine is what? Theta. And sine theta output is what? It is a number. So it is also dimensionless. Similarly, e to the power x. So e to the power, constant to the power, I will not put any unit. I will put what? Number. Number to the power number. E to the power some number I will put. So e to the power x. So x will be what? Dimensionless. So e to the power x is dimensionless, means output is dimensionless, and e to the power x, here power is also what? Dimensionless. Log x is dimensionless, and x will be also dimensionless. I cannot take the log of any quantity, like what is the log of meter per second? Can I find? Can you find? No. So we have to find we can find the log of any numeric constant. So that's why input of the log is also dimensionless. This everybody got or not? So what I can say, trigonometric function exponential e to the power x and log does not have dimension because they will give the numeric constant. Okay, and we can say what? And trigonometric function will put the angle, so theta, or we can say another way, and input of trigonometric function, comma, power of e exponential, that is what? X, and input of log, that I have taken what? X, are also okay. So what I said, like sine theta, if I am saying, so theta is dimensionless as well as sine theta is dimensionless. If I am saying the e to the power x, so x is dimensionless as well as e to the power x is dimensionless. If I am saying the log x, it means what? X is the dimensionless and as well as log x is dimensionless. So remember this note. Next class I will discuss the problem on this and then I will continue. Okay. Completed. Okay, so one or two questions I will discuss, then I will discuss about the application of the dimension, and then we will learn the unit conversion. Track 3 is not the practical physics. Track 3, that regular syllabus will be there. Practical we will not teach separately, we will teach parallelly. Okay. Okay then, bye bye. Good night. We will get to know in the next week who will take track 3. Okay. Bye bye bye. Yeah, notes is enough for this week. Just read the notes properly, okay? And if you have any book, you can solve few questions from the book. Otherwise, notes problem everybody has to solve at least properly, okay? And material, who has then material they can solve, okay? Otherwise, notes is enough. Okay, bye bye.